Going live. Talking about limits and derivatives today. And this is the one?
Yeah.
Perfect. All right, so limits and derivatives. Well, these problems, you'll notice that all of these problems are just rational functions, right?
Yeah.
Every one of these is a rational function. Well, these are all the same. Notice this is saying from at going the limit as x goes to -3 from the right, from the left, and the limit as x goes to -3. In order for this to even exist, these two have to be equal to each other. You understand that?
So the limits of sorry, I'm gonna try to see if I can annotate the screen. I can't really do that. So 19 and 20 need to be equal.
Correct. In order for 21 to exist.
Okay.
Okay. So and really you just finished a unit on rational functions, right?
Yeah.
So that's exactly what this is. This is just a rational function. And so I'm going to do this really quick. The rational function, if I were to graph this, first of all, I would take an x out, and then I would take a factor out of 2x and x. Let's see, 9, 3. So this would be, is that going to factor?
Plus 6 minus 3.
It can't be 6 and 3 because it's got to multiply to 9.
Oh, I thought it would multiply to 2 and 9.
Well, the 2 I already brought here.
Oh, okay.
So yeah, okay, but 3, yeah. So 3 is going to be there and 3 is going to be here. And this is going to be a plus and that's going to be a minus. I think that'll work. -3 and a +6. Yeah, that works. So there's my factor. And what that means is my I don't have any removable discontinuity, right? I've got my y-intercept, or my x-intercept. I get that from the numerator, right? The x-intercept is 3. See that? The vertical or the asymptote, the vertical asymptotes, there's going to be 3 of them. One of them is going to be at 0, at x equals 0. One of them is going to be at x equals 3/2, and one of them is going to be at x equals -3. Right? So
yeah,
there's one of them. There's one of them, and this is the one in under review. Now I'll tell you right away. I know that this is going to be does not exist. And can you tell me why I know that? Did you remember from rational functions why I know that's going to not exist?
It's because there's an asymptote at x equals -3.
Not just an asymptote, but did you learn about multiplicity of vertical asymptotes?
I kind of forgot about that.
So if the multiplicity of a vertical asymptote basically means what is the power of that factor. So here's the factor that gave us the asymptote of -3, right? You see it?
Yeah. Yeah.
And the power is 1. It's an odd power. By the way, this also has an odd power, and this also has an odd power. All 3 of them have an odd power. And because of that, whenever it has an odd power, the asymptote gets approached from 2 different directions. It's either going to go that way on the left and that way on the right, or vice versa. This way on the left and that way on, I'm sorry, this way on the left and that way on from the right. Understand? So I know this is going to be does not exist. So what I will do is I'm literally just going to graph this rational function, and I can see what my x-intercept, I can see my x-intercept is going to be 3. Oh, I already got that. And oh, by the way, this has a power. This x-intercept has a multiplicity as well. What's the multiplicity of the x-intercept?
1.
It's 1, which is odd, which means it goes through the axis.
All right.
You understand that?
Yeah.
And the fact that it was bottom heavy, means I have a horizontal asymptote at 0.
Okay.
And I only have 1 0. My only 0 is that one. My only 0 is 3. Now, what's my y-intercept? Can I have a y-intercept? I can't have a y-intercept when I have a vertical asymptote, right? So I won't have a y-intercept, so none. So what I'm going to have to do is I'm going to have to find just one more value somewhere. So let me find the value of 2. What's f of 2? I'm plugging 2 into the top. I get -1. And 2 into the bottom, I get 2 times 1 times 5. So is that a positive or a negative value?
That's a negative value.
That's right. So it's down here somewhere. So what's going to happen is I'm going to go like this, approaching the asymptote there. And it has to go through, but then it has to come back down and approach the horizontal asymptote because it always does that.
Okay.
Got it? Now I can find all of the other details that I need just based upon the multiplicities. All the other details right here. What has to happen on the other side of this vertical asymptote? What has to happen?
It has to go up.
That's right. It has to go up. And is it going to cross and go down, approach this one down? 0? How do I know it's not going to cross? What would I have if this crossed?
It'd be a quadratic. Or no, it would be an x-asymptote.
I would have another x-axis, right? Or x-intercept, right?
Yeah.
So I know that's not going to happen. So what has to happen at some point?
It's going to have to turn back.
It has to turn back and go up. You understand?
Yeah.
And then what's going to happen over here on this side? Because of the multiplicity of this, what has to happen?
It's going to have to
it has to do the same thing. It has to approach from the opposite side. Remember that?
Yeah.
And is it going to go through? Can it cross here?
No.
So what has to happen?
It has to come back also.
It has to come back. Do you understand?
Yeah.
And what has to happen over here?
It's going to have to approach from the other side. So it's going to have to be up.
That's right. And this is going to approach there. So that's my graph, rough sketch. That's a rough sketch of my graph. Make sense?
Yeah.
Now, let's answer these questions. What is the limit? And by the way, this isn't the way you would necessarily do this problem. It took a long time. All you really needed to do was plug in something over here. Instead of plugging it, I just wanted to show you this because you're a new student for me. I wanted to show you that trick about rational functions, because all of these things are questions about rational functions right now.
Oh, okay.
So what's the limit as x approaches negative, as x approaches -3 from the right? That would be right here. Do you understand?
Yeah.
But generally, all you have to do is plug in a number to the right of -3, really close to it. Like, for instance, -2. Unless -2, or unless a number between -3 and -2 is a 0, then you would have to plug in something even closer, like -2.9. You understand? But generally, if you just plug in f of -2, you'll see, oh, that's just going to be, by the way, I'm plugging it into this one over here. It's easier to plug it into here for me because I'm just trying to see if it's a positive or a negative number. When I plug in -2, I get -5 over -2 times -7 times 1. So what's the sign of that?
Sorry, could you repeat that?
Yep. What's the sign of that if I plugged it in? Like, first of all, do you understand how I did that so quickly? Where I got that from?
I was kind of writing down, like I was kind of writing down some notes, so I didn't really hear that
Okay.
section.
Okay. Hey, remember, all of this is recorded on YouTube. So that's
Yeah.
one of the reasons I don't want you to have to, I want you just to sit back and listen and get
Okay.
it, and you can go back later and watch it and write notes down.
Okay.
Try not to do that, because you're going to be able to see that again and hear it again. Okay.
Yeah. Okay.
So the best way to plug this in isn't by plugging it into here. The best way is to plug it into this over here where you factored it.
Okay.
So I'm literally, because I'm just trying to find the sign. So when I plug in -2 here, I get -5. Here, I get -2. Here, I get -7. Here, I get +1. And to be honest with you, it didn't even really matter. All I really needed to do was just put negative over negative times negative times positive. That's really all you have to do.
Yeah.
You understand what I mean?
Yeah.
So what is the sign of that if I have an odd number of negatives?
With all number of negatives. That means that the entire answer will be negative.
Correct. So if it's an odd number of negatives, it's a negative. If it's an even number of negatives, it's positive.
Yeah.
Hey, and that's what we had, right? You see how it's down here?
Yeah.
So what I'm saying is you could have just done that. You didn't have to start over here at 2. The reason I started over there is because I wanted to show you that all you really needed was 1 point, and then you could figure out everything else by using multiplicity. You could
Yeah.
actually work your way from right to left if you wanted to.
Yeah.
Does that make sense?
Yeah.
So tell me about 20. What's the answer for 20? So this one is going to be what? Positive or negative infinity?
The answer is gonna be negative infinity.
That's right. It's negative infinity, because here's why. Look, when you get on this graph, see how I'm on the graph? The
Yeah.
closer you, as x gets closer and closer and closer to -3 from the right, what's y getting closer and closer to?
Negative infinity.
That's right. And when I jump on the graph to the left of it, and as I get closer and closer, right? As I get closer and closer and closer, this point gets closer and closer and closer to what?
Positive infinity.
You got it. Make sense?
Yeah.
All right. Now this next one's a little different, because this is a rational function, but it's not a polynomial rational function that's got absolute value. But this, we can figure this out with a little analysis. So what I have here, first of all, I want you to notice that I can factor a -1 out of the top of this. That's really important.
Yeah.
So really what my function is -1 times x plus 8 on the top, and then it's just absolute value of x plus 8 on the bottom.
Okay.
Now that's important, because let's just plug in some things and see what happens. When I plug in, sometimes it's best just to use uh, a t-chart and plug in some stuff. When I plug
Yeah.
in, and notice I want to plug stuff in close to what number?
-8.
Good. So let's just put -8 right here. And let's go the -7, -6, and maybe -9, -10. Got it?
Yeah.
Well, first of all, when I plug in -8, what am I going to get?
0.
I'm going to get 0 over 0,
It needs to be simplified further.
which means it's indeterminate.
Oh, okay.
That's what that means. It means I don't know what's happening there. Because if I could plug in -8, if I plugged in -8 and I got an answer, then that's the answer for all 3 of these. If you plug
Right.
in -8 and you get an answer, then that's your answer. For example, what's the limit as x goes to 0 for this function? What's the limit as x goes to 0?
-1.
Yep, it's -1, because you'd plug 0 in here and here, You'd get -8 over +8, which is just -1.
Yeah.
Got it? But you can't do that for -8 because you get 0 over 0. So you're going to have to do a little bit more analysis. So what happens if I plug in -7? What would I get if I plug in -7 to this function?
You'd get
What's
15
-7
over
plus?
1.
Nope, careful. What's -7
Oh, 1,
plus 8?
1.
Yep.
1.
-7 plus 8 is 1, but then there's a negative in front of it, right?
So this becomes a -1.
Uh-huh. So this is -1. How about -6? When I plug in -6, what do I get?
-2.
-6. Look at it carefully. -6 plus 8 is what?
-2. I mean, +2.
But there's a negative, and what's -6 plus 8 on the bottom?
2. Because
So
-2 over
what's
2 is
negative?
-1.
There you go. It's -1. You understand what I'm saying?
Yeah.
And what do you think -5 is going to be?
-1.
You got it. In fact, anything that when you're on the left of this, I'm sorry, on the right of it, anything. So let's look at our graph. Here's -8. And whenever I plug in things to the right of it, my answer is -1. So that's my graph.
All right.
You understand? Now, what
Yeah.
happens when I plug in something to the left of it? When I plug in -9, let's do this. What's -9 and -9? What's the numerator going to be?
-9 plus 8 is -1.
So what's the numerator going to be?
The numerator is going to be 1.
Good. And what's the denominator going to be?
1.
And what's 1 over 1?
1.
And what do you think you're going to get when you plug in -10?
1.
You got it. So what's happening to the other side is this. Do you understand?
Yeah. So as it approaches from the right, y approaches -1. And as it approaches from the left, y approaches 1.
That's right. So that's +1. That's -1.
Oh, would it be the other way
And
around? Oh, no, it's okay. Sorry. I just missed.
yeah, you see why?
Yeah.
And so what's the answer for number 26?
Does not exist.
That's right. Because it has to be the same from both sides.
Okay.
Yeah, does that make sense?
Yeah.
All right. So now here we have a piecewise function. And so again, what we're going to have to decide is, are they asking, they're asking for the limit as x goes to -6. So the only thing that doesn't matter is what it actually equals.
Yeah.
That doesn't matter. In order for this limit to exist, these two have to be equal to each other.
Okay.
Does that make sense?
Yeah.
So just plug them in. What's this? If I plug in -6 to here, what am I going to get? -6 squared minus 4. That equals 36 times 2 is 72 minus 4, which is 68.
68.
And if I plug in -6 here,
-72 plus 4. That is -68.
so does the limit exist?
No.
Does not exist. Got it?
Yeah.
Same with this one right here. This doesn't matter. Who cares? Doesn't matter. You don't even have to check it. Now, the time you would have to check this is if it asked if it was continuous.
Right.
If it said, is this function continuous, then that would be where the limit would have to work, and that function value would have to also be the same thing as the limit.
Yeah.
Okay. So now the problem with this is I can't plug this in, can I? If I plug in -1, what am I going to get?
If you plug in
I'm gonna
-1, you'll get a denominator of 0.
And I'll get a numerator of 0 as well.
It's gonna
It'll
be
be
0 over
0
0.
which means, like you brilliantly said before, it's indeterminate, and you have to cancel out the factor. So what's the
Alright.
trick to doing that? I'll do this in green on the bottom.
So you have to multiply by the conjugate.
Very good. Good job. Okay, which is what? What's the conjugate?
Negative, as it means root of 3 minus x plus 2.
Perfect.
On the numerator and the denominator.
Perfect. Good job. Good. And don't actually multiply it in the denominator. Just leave it there, right?
All right.
Leave
Yeah.
x plus 1 and the square root of 3 minus x plus 2. Just leave it like that.
Yeah.
And then in the numerator, the difference of perfect squares, the square root's going to go away, right? And you're just going to have -4.
Yeah.
Which equals, I'm going to simplify this above it, which just equals -x minus 1. Which equals -1 times x plus 1. Right?
That's what cancels out.
And that cancels out. So I just get, so this just equals -1 all over the square root of 3 minus x plus 2. And now I can plug in, whoops, that should be a minus there. Now I can plug in -1. And I'll get what when I plug in -1 to this thing?
You'll get -1 over 4.
-1 over +4, which is -1/4. Good. So there's my limit from the, which way, left or right?
From the left.
Perfect. And now do the same thing with this other one, but now this is a little bit easier. We just have to, it's probably got to, if I plug in -1, I'm guessing that I'm going to get 0 over 0 again, right? Which means I can factor and cancel. So this is going to be, is that true? No, this doesn't factor and cancel. Oh, maybe I just get, no, you know what? No, maybe when I plug that in, maybe I just get -1/4. I think that's what happens. Let's try it. -1 squared plus 6 minus 3. So that's 1/7, that's 4. And the numerator, when I plug in -1, it's -1. How about that?
All right.
So it's -1/4 is what the value is going to be when I'm coming from the right, what I would expect the value to be.
Okay.
Okay.
Yeah.
And if you graph these, you would see the graphs, they would actually be, now it's not equal to that, right? It's not, the value at -1 is actually equal to 30. So it's not continuous. Do you understand that?
Yeah.
Have you talked about continuity yet?
Yeah.
Yeah, it's not continuous, but the limit does exist, and the limit as x approaches -1 is -1/4, which means that's what you would expect the value to be, whether you're coming from the left or the right. You would expect the value when you approach -1, you would expect the value to be -1/4. That's what you would expect, whether you're coming from the left, whatever that's doing, or from the right, whatever that's doing. That's what you would expect. The function value is 30, it's way up here, but you would expect the function value, whether you're coming from the left or the right, to be -1/4.
Yeah.
That's the idea behind limits. All right, they said evaluate these limits using algebraic techniques. Algebraic techniques. Can you tell me what they mean by that? Algebraic techniques?
I'm not really sure. I think they might want us to substitute or find the asymptotes.
Yeah, that's what I would do. I would just find the asymptotes. I would recognize that this is a rational function. And so what I would do is I would find the horizontal asymptote, the
Yeah,
Hasse. That seems algebraic to me, right?
yeah.
The horizontal asymptote is going to be what? When it's bottom heavy, what's the horizontal asymptote?
The horizontal asymptote is 0.
Right.
Y equals 0.
And the horizontal asymptote is what is the end behavior of the graph. So as x goes to positive infinity, then you would expect it to be 0. That is my algebraic technique. I'm not sure what they mean. The other thing is to just kind of plug in. Another way, maybe algebraic technique, is to plug in some really big numbers, right? T-chart. This is an
Yeah,
algebraic technique, perhaps. Plug in 100 for x. You're going to get 1 over 88. Plug in 1,000. You're going to get 1 over 988. Plug in 10,000. You're going to get 1 over 99988.
yeah.
Oh, too many. Here, I'll just put another 0 in there. You get what I'm
Yeah.
saying? And what does this thing get closer and closer to? What does this value get closer and closer to?
Sorry.
1 over a really big number
Yeah,
is closer and closer to what?
0.
0. So that's another algebraic way. I'm not sure if that's what they mean by that. But
Yeah.
I would, again, and there might be another way also that they're talking about. But so for this one right here on number 8, what is the Hasse for this?
The Hasse for
Again,
this one is also y equals 0.
that's right. How about number 9? What's the Hasse?
The Hasse is gonna be 5 over 3.
Perfect. Okay, I'm realizing another algebraic technique that you could have used.
Yeah.
If you divide everything, this might be what they mean by algebraic technique. If you divide everything or multiply everything by 1 over x squared, if you multiply everything by 1 over x squared, you're going to get 5 plus 7 over x squared all over 3 plus 3 minus 1 over x. And what happens to these things as x gets bigger and bigger and bigger? What happens to these? This might, I don't know if this is considered an algebraic technique or calculus technique, but this is something that you'll do when you, as you get further in this, is these things go to 0.
Okay.
And that's why my answer goes to 5/3.
All right.
Make sense?
Yeah.
That might possibly be what they meant. Next page, if f of x equals that, find the limit as x goes to 2. All right, so now we're actually doing derivatives. So this is the definition of a derivative. A derivative is basically finding the limit as x approaches 2 of, do you notice how this is rise and this is run? You see how there's y minus y over x minus x?
Yeah.
So we're basically finding the slope. This is the slope. We're finding what's the limit of the slope as x gets closer and closer to 2. That's what they're asking us. If I'm on this graph right here, which is a cubic, right? What's the limit of the slope as you get closer and closer to 2? So this graph right here, just to give you a visual for it, is going to be going like this, right? Something like that.
Yeah.
Sorry, that was a bad job drawing it. That's doing something like that. And
Yeah.
2 is somewhere on here is 2. I'm not sure where it is, but let's say 2 is right here. Let's say that's 2. So they want to know what's the limit as x gets closer and closer to 2. As I get closer and closer to 2, my x value gets closer and closer to 2. I'm on my graph. Basically, what's the limit of the slope of that line, of that, or at that point? And in other words, this is like a tangent line right there
Yeah.
that they're wanting us to find. Okay, so that just gives you the visual for it. All right, so now we don't need that visual to actually do this. We can just do it. So what we're going to do is I'm going to plug in f of x is this. So let's just write that 3x cubed plus 4x squared minus 6 minus f of 2. Let's plug in 2 to find f of 2. If I plug in 2, I get -3 times 8, which is -24. Got it?
Yeah.
You with me? Plus 2 squared, which is 4 times 4, which is what? 16 minus 6. You with me?
Yeah.
So it's minus 14. 24 plus 16 minus 6. You with me?
Yeah.
Okay. All over x minus 2.
Yeah.
So these become positive. What's -6 plus 14?
20. Oh, wait.
Nope. -6 plus 14?
Oh, sorry. 8.
+8. Now guess what's going to happen to this top up here?
That can factor.
It's going to have a factor, and the factor is going to be 2. Now, do you remember using synthetic division?
Oh, yeah.
So let's do synthetic division to do this. This is kind of tricky. So I'm going to go -3, +4, 0, -6, and I'm going to put a 2 on the outside, right? And I
Yeah.
should end up with a 0 here if it's a factor, yes?
Yeah.
So drop the 3 down, -3 down, multiply, that's -6, add, that's -2, multiply, that's 4. Oh, sorry. This shouldn't be 8. This shouldn't be -6. This should be +8.
Yeah.
You see that? That was my fault. I was looking at the blue. So this is -4, add down, multiply. Hey, perfect. So look at what I've got. So that means that
Yeah.
this numerator actually factors into
Yeah.
-3x squared minus 2x minus 4 times x minus 2 all over x minus 2. And now I can cancel the x minus 2's. You understand?
Yeah.
So what is the limit as x goes to 2 of this mess?
As x goes to 2, the
Now
limit.
I can plug 2 in, right?
Yeah.
2 squared is 4. That's -12. Plus a -4 is a -16. Minus 4 is -20.
-20.
Okay, you know what that means? That means that this point right here, you know where this 2 really was on the graph? Look at my picture again. This 2 is probably over here somewhere,
Yeah.
or it could have been over here somewhere, because the slope of the tangent line is -20, so it's going down.
Okay. Yeah.
I'm giving you a little bit of a foreshadowing of what you're going to be learning in calculus, or what you're going to be learning next.
All right. Yeah.
In fact, if we wanted to read off what that equation is again. What was the equation they gave me?
Sorry.
That's okay. I can't see it. -3x cubed.
-3x
-3.
x cubed.
Mm-hmm.
I can't remember it either.
I can find it. Plus
Plus
4x squared
4x
minus 6.
squared minus 6.
Plus 4x squared minus 6. If I go to my graph and I go to -2, look where -2 is on my graph. If I go all the way up to -2, you see that point?
Yeah.
That point, the tangent line at that point up there, which is at about -2 comma -31 maybe. You see what I'm talking about?
Yeah.
That tangent line, nope, -2, -33. The tangent line right there is at has a slope of -20. That's essentially what you just found out
Yeah.
by doing that problem. Okay.
All right.
Questions about that one, or can I move on?
We can move on.
All right. So this next one, same deal, right? So we're just going to have to be careful plugging in these numbers.
Yeah.
So f of x is 2 times the square root of 3 minus x squared minus f of 1. Plug in 1 and you get what? 2 square roots of 2? Did I do that right?
Yeah.
All over x minus 1.
Yeah.
Okay. What's the limit as x goes to 1 for this mess? Again, if I plugged in 1, well, what am I going to get on the top and on the
0.
bottom?
0.
I'm going to get 0 over 0, which means I could have done something to simplify this in the very first place. So let's do that. Let's multiply this by, remember that trick you just taught me, or you just reminded me of?
The conjugate.
Yeah, we're going to multiply by the conjugate, which is, I'll go ahead and write it up here. 2 root 3 minus x squared
plus
2 root 2. Yep. 2 root 3 minus x squared plus 2 root 2. And when I do that, in the front, I get 2 times, whoops, not 2, 4, right? Don't forget to square the 4. 4 times 4 times 3 minus x squared. Got it? See how I did that?
Yeah.
Minus 4 times 2, which is 8.
Yeah.
Minus 8. Good. All over x minus 1 times that mess. I'll just leave it like that for now. So let's simplify this. This is 12 minus I'm a little concerned about this. 12 minus x squared minus 8. I did something wrong. What did I do wrong? That. That's going to be a 2, not a. Something's not right. I did something wrong. Because I'm going to get, with this, I'm going to get negative. That's going to be a negative x squared plus 4. Which if I factor it out, it's going to be a negative x squared minus 4, which is x minus 2 and x plus 2. But I should have a factor of x minus 1. That cancels out, so I did something wrong.
Yeah.
What did I do wrong?
I'm not sure.
Let's see. Was it supposed to be 2 squared is 4 times 2? That's right. This is just the square root of 8. So that's minus 8. This one is going to be what's that times itself? It's I have to do 2. I have to do 2 times 2, right? When I multiply this to here, these multiply as well as this. So I'm pretty sure that's right. Did I do this wrong? Is the square root of 8 not correct? Did we plug that in wrong? When I plug in 1, 3 minus 1 squared is 2. 2 root 2.
Yeah.
Seems correct to me. So let's try that again. 4 times 3 minus x squared minus 8.
Yeah.
Seems like we did that right.
Yeah.
So why is the x minus 1 not canceling out? I'm not seeing something. Are you seeing something? Something's wrong.
Yeah, I don't see anything. Should I put this in Desmos and see what happens?
Yeah. 2 root 2. Oh, duh. I'm an idiot. I see it. I see it.
Oh, what happened?
Yeah. So I just didn't distribute this incorrectly. This is 12 minus 4x squared minus
Oh,
8.
okay. Yeah.
Yeah. So it's negative 4x squared minus or plus 4.
Yeah.
So that factors to negative, that turns into negative 4 times x plus 1, x minus 1. That's it.
Yeah.
I knew it had to happen. Okay, so that's my, so then my numerator is going to be x minus, or the denominator rather is going to be x minus 1 and 2 root 3 minus x squared plus 2 root 2. So these cancel out. So you're just going to get negative 4 over x plus 1 all over 2 square root of 3 minus x squared plus 2 root 2. So now when you plug in 1 to that, now I can find the limit of that as x goes to 1. And I'll just get negative 8 on the top. And I'll get 2 root 2 on the bottom plus 2 root 2. So that's 4 root 2. So it's negative 8 over 4 root 2, which
Negative,
simplifies to,
negative 2 over root 2.
which is just, if I multiply by root 2 and root 2,
Negative 2 root 2.
it's just negative root 2.
Negative root 2.
Got it?
Yeah.
That was fun. All right, you get the hang of how this works now?
Yeah.
All right.
Is it okay if we just skip over these because there's like more that I need to go over?
Absolutely. That's why I was going to ask you. Do you want to skip those? You think you can do those on your own now?
Yeah.
All right. So can we go to page 8? Is this good?
Yeah.
All right. It says for the function graph below, fill in the table with given information. After filling in the table, write 3 pieces of information that must be true in order for the function to be continuous. Here's what I was talking about. For it to be continuous, the limits have to be the same and the function values have to be the same. Right? So this point right here, you see how at negative whatever that is, I can't really read, negative 6 maybe. You see how that looks like the limit exists because there's a hole there. You see how the limit exists, but the function value has to exist.
Yeah.
The function value has to also be there. So the function value would have to be 5 for that one. So for the limit to exist at x equals negative 6, it says, is the function defined? If so, what is its value? Well, the value has to be 5 because that's what the limit is at that point.
Yeah.
Make sense? What is the value of the limit as x goes to, I can't read that. That says a. A from the left.
Yeah.
The value as x goes to a from the left is 5. From the right, it's also 5. What is the value of the limit? Oh, sorry. This question says, is the function defined? but it looks like it's not for that point because I don't see a point anywhere.
Yeah.
So the answer for that is no. The limit from the left and the right are both 5. So the limit as x goes to a is 5. And is
Yeah.
it continuous? Is g of x continuous? The answer is no.
All right. Yeah.
So it says after filling the table, this is what I was reading first. Write 3 pieces of information that must be true in order for a function to be continuous. So the 3 pieces of information are, it has to be defined, it has to have a limit. Let's see. Right, 3 pieces of information that must be true in order for a function g to be continuous. So the 3 pieces are, the limit from the left is equal to the limit from the right is equal to the function value.
Yeah.
Those are the 3 pieces of information.
Yeah.
So f of a equals the limit as x goes to a from the left of f of x equals the limit as x goes to a from the right of f of x. Those are the 3 pieces of information that must
Yeah.
be true. Make sense? Like I
Yeah.
was talking about before. So at -3, is that this one right here? Is the function defined? Yes, it is. Yes, 2. Because see how that's a solid dot there?
Yeah.
I think that's a 2. Forgive me if I'm reading these wrong. What is the value of the limit as x approaches g of x from the left? So jump on the line and go toward it. What do you expect it to be?
It would be 2.
It would be 2 as well. How about from the right? What would you expect it to be?
It would be -4.
-4. So what is the value of the limit?
Value of the limit is 2. Oh, does not
DNE.
exist. Does not
Yep.
exist.
And is it continuous?
No.
No. How about at 0? Let's look at 0. Do we have any problems at 0?
No.
We have no problems. What is that, 0, 0?
Yeah.
So basically all of these are 0, 0, 0, 0, 0, and yes. How about at 2?
At 2.
Is that the vertical asymptote?
Yeah.
Okay, so is the function defined? No. What's the value from the left? Positive infinity. From the right? Negative infinity. What is the value? DNE? No.
Yeah.
How about at 6? That's this one right here. What's the function value?
At 6, the function value is 1.
Good. What's the limit from the left?
On the left is 4.
Good. From the right?
It's -1.
Good. So does the limit exist?
No.
Does not exist. And is it continuous?
No.
No. And how about at 8?
At 8,
I'm guessing
okay.
it's this one right here.
Yeah, at 8, the limit is the function defined?
Well, what's the
Yes.
function?
The function is
What's the
defined at
function?
-4.
The function's -4, but the limit is
Negative
-1, right?
-1, yeah. Or -2. I can't really no, -1, sorry.
It's kind of hard for me to read it. I think it's -1. Okay. You see how that works?
Yeah.
Yeah, it seems like you do. All right, it says the next one, determine whether or not each function is continuous at the given values. So at 1 or at 0 and at -6, basically it's going to be continuous as long as it's not a horizontal asymptote or a hole, right? For these
Yeah.
ones. So let's see if we factor out an x. If we factor out an x, we'll get x plus 6. And if we factor an x out of the top, we'll get x minus 6. So there's going to be a what at 0?
There's gonna be a hole.
Good. So at zero,
Zero
at
is not.
zero, not continuous.
Yeah.
And the reason is because of a removable discontinuity, right?
Yeah.
How about at -6?
At -6, no.
And what's the reason for it?
Because the denominator would be 0.
Which means I have what at -6?
I'm not sure.
Remember Vasey's?
Oh, a vertical asymptote.
Yeah. So that's called an infinite discontinuity, I believe is what they call it.
All right.
Okay. So for number 2, again, let's factor and cancel. We're going to have an x and an x plus 3 on the top, and on the bottom we're going to have an x and an x minus 3. So I'm going to have a whole where? An RD at 0 comma what?
At 0, 0.
Not 0, 0. Remember, you cancel out the x's and you plug it into your new equation to find the whole. So these
-1.
x's cancel. Yep, at -1. Got it?
Yeah.
So so the question is it continuous at the given point? At c equals 0, is it continuous?
No.
It's not, because there's a hole there.
Yeah.
And that hole, if this had said -1, it would have been continuous. But it doesn't say -1, it says +1.
Yeah.
Do you understand? So this actually almost was yes. You almost had yes for this, because if they would have defined this, if this was -1, then it would be yes, then the answer would be yes. You understand
All
why?
right. Yeah.
Because it's like you're filling in that hole.
Yeah.
So for this last one, it's going from the right. It's so again, what we're talking about here, let's find out what would if I plug in 0 for this one, what would I get? What's e to the 0?
If you plug in, that would just be 1.
Correct. So 2 times 1 is 2, right?
Yeah.
And what if I plug in 0 to this one? What am I going to get?
You'd get.
You'd have a problem, wouldn't you? So we're
Yeah.
gonna have to factor that out. So it's x squared times x plus 2 all over x squared. So if we
Just
cancel
x
that
plus
out,
2.
yeah,
Just
what we would have an RD. We have an RD at 0 comma 2, right?
yeah.
So is this continuous at c equals 0?
Yes.
It is, because this and this and this are all saying that it would be that's what you would expect it to be. So the answer
Yeah.
is yes. Okay,
Yeah.
that makes sense.
Yes, that makes sense.
All right. Do you want to do this page, or what do you want to do now? We have 5 minutes.
Oh,
Oh, see, now we're talking about the derivatives again.
Oh, yeah. I wanted to go over derivatives. I wanted to go over specifically the f of x minus, no, the f of x minus h minus, the f of x plus h minus f of x over x minus h. We had learned how to do derivatives in class, but the way I always did them was I would substitute the value of f prime back into the function, and I'd do it like that. But I wanted to know how
Okay.
to do it with the f of x minus h method.
Okay. So do you
This one
want to do it on this one?
yeah.
On page 9? Okay. So what's that formula again that you're
It's
telling me?
f of x plus h.
It's the limit. It's a limit of something, right?
Oh, yeah, it's the limit of
As h goes to 0?
I forgot.
Or, well, tell me what the formula is and I'll tell you what it is.
Okay.
F of x,
Formula derivatives.
would you say f of x plus h? Minus f of x all over
H.
H, right?
Yeah.
Yeah, and that's the limit as H goes to 0. Right?
Yeah.
Okay, so this is the same. This is essentially the same thing as the other one that we did. It's just written in a slightly different way.
Yeah.
But it's
So
the same thing. This is your rise, and this is your run.
Yeah.
The height is your run. This is your rise, and this is your run. Okay?
Yeah.
So what we're going to do is we're going to plug in H or X minus H into that equation. So I plugged it in up here. So there's my f of X plus H. Actually, here, let me do this. Let me erase this and make it red so you can see what I'm doing. This is f of X minus X plus H. So this is X minus H squared minus 4. See, I've plugged in, that's the red one plugged in. And then minus f of X all over H.
Yeah.
So the same thing is going to happen as before. Things are going to magically disappear. So this is going to be negative X squared minus 2xh plus H squared. You follow?
Yeah.
Minus 4 minus, oh, let me get rid of f of X. Let me plug in f of X. F of X is negative X squared plus 4.
Yeah.
So minus, whoops, didn't mean to do that, minus negative X squared plus 4 all over H. The limit as H goes to 0. So this equals the limit as H goes to 0 of negative X squared positive 2xh negative H squared minus 4 plus X squared minus, I'm missing something. Shouldn't have a minus 4 here. Was it? Oh, this should be plus, shouldn't it be?
Yeah.
Not minus. My bad. So this is plus, I made a mistake there. X squared plus 2xh plus H squared minus 4. Distribute that in, this should be a minus here now. Sorry, I made that mistake.
Okay.
Oh, and this should be a plus 4, man. All kinds of mistakes. This should be a plus 4 here. There we go. I knew something wasn't right because it had to cancel out. So
Yeah.
this is plus 8 minus 4 all over 8. So now what cancels out is the 4s are canceling out, the X squares are canceling out, and I get the limit as H goes to 0. Now I can factor an H out of H times negative 2x minus H all over H. So now the H's cancel out, and I just get the limit as X or as H goes to 0 of negative 2x minus H, which just equals negative 2x.
All right. So, okay. So that's the sum. So you just substitute the 0 back into the H.
Yep.
So negative 2x.
Because now you can. At that point, you can substitute it back in.
So negative 2x. And so from that, what we were supposed to do was kind of substitute the points back in with the calculate for the C on this page.
So now they're saying, so this is f prime of X. It's negative 2x. So f prime of negative 2, plug in negative 2 for X, and you get positive 4.
Yeah.
F prime of 1, you get negative 2.
All right.
And then it says find the equation. This is D. Find the equation of the tangent line at X equals negative 2.
Oh,
so
yeah, I'm good with that part.
That's fine. Okay.
Yeah.
Right. And so what those things were, remember what I was talking about before? Let's look at what that is. This would be your graph. It would be here, and then this would be your original function. It would be this, right?
Yeah.
And what did I say earlier today? What did I say about these derivatives here? What
It'll
did
be
I
the
say about
slope. It'll be the slope of the tangent line.
the slope of the tangent line? So the tangent line right here, that's the tangent line. And the slope of that is +4.
Yeah.
That's what that is. This line here, I'll do this in black. At 1, the slope of the tangent line is -2. See how it's down, going down? The slope of that m equals -2 of that line.
Yeah.
That's what basically the derivative is. It calculates the instantaneous rate of change for every point on your graph. It's really pretty amazing.
Yeah.
And the reason that's so good is because really what you want is you want to find the max and min points. So to find out where the rate of change equals 0, you set the slope equal to 0. So here's my slope, my derivative. If I set that equal to 0 and solve it, I get 0. And that tells me that at 0 on my original function, the slope of that tangent line is 0, meaning it's a horizontal line, meaning it's not going up or down, it's plateauing. It's either a maximum point or a minimum point.
Yeah.
And that's kind of the purpose of derivatives and what we're doing. Okay.
Yeah.
All right.
Yeah. Other than that, I feel like I understood everything. Those were just the ones that I really struggled with.